Whether you operate one forklift or thousands, one location or hundreds, the new My Toyota customer portal can help you optimize your operation and material handling equipment. This one-stop, free-to-use platform is designed to help you take control of your information and make smarter decisions, all at the touch of a button. Register and access your data today at my.toyotaforklift.com. That's my.toyotaforklift.com.
The New Warehouse Podcast, hosted by Kevin Lawton, is your source for insights and ideas from the distribution, transportation, and logistics industry. A new episode every Monday morning brings you the latest from industry experts and thought leaders. And now, here's Kevin.
Hey, it's Kevin Lawton with the New Warehouse Podcast, bringing you a new episode today. Today's episode, I will be joined by Angus Pacala. He is the co-founder and CEO at Ouster, and Ouster provides Lidar technology for automation and sensing. So automated vehicles and automated guided vehicles can see where they're going and know where they're going. They provide technology to some customers that we may be familiar with who have been on the podcast before, including Syngin, Third Wave Automation, Vector Robotics, and Valio. So we're going to talk to Angus today. First, we're going to find out, how he came to kind of start Ouster as the co-founder here. And then we're going to talk to what is Lidar? Why does Lidar matter for the warehousing industry, and how is it being applied today, and how is it continue to grow and will be applied going into the future? So Angus, welcome to the show. How are you today?
I'm doing well. I had a rainy drive in.
Oh yeah. Where are you based out of?
We're based in San Francisco.
Oh, okay.
Having interesting weather for the last week.
Ah, interesting. I was going to say, it's nice and sunny here on the East Coast in New Jersey, so no rain today. But
I'm actually from New Jersey. Yeah, I'm from New Jersey originally, so.
Oh, really?
East Coast transplant, yeah.
Okay, all right, very cool. So we got a local guy here. All right, very good. All right, so why don't you tell us a little bit about, we know where you're from originally now, but tell us a little bit about some of your professional background here and how it kind of led you to being a co-founder in this company, Ouster.
Sure, yeah. So I came out to the West Coast to go to school and get a degree in mechanical engineering and then a master's in mechatronics.
Okay.
And I've really kind of been innately interested in automation, robotics, and really powerful machines doing interesting and important work and affecting the physical world in a positive way. And Lidar sensing is kind of the key input to actually making any machine do important, safe, and efficient work. So I've been working in Lidar for quite a while. I co-founded a previous company in the space called Quanergy Systems in 2012.
Okay.
And then in 2015, my co-founder at Ouster and I, Mark Frichtel, we realized that there was another way to build Lidar sensors with digital technology. And we also realized that there was a much broader landscape of use cases for Lidar than just automotive.
Okay.
Actually, in 2015, if you think back on where we were out in Silicon Valley, and Silicon Valley was really, really hyped on autonomous vehicles,
yes,
robotaxis. But we realized that there was an opportunity to build Lidar sensors and push this automation technology into industrials, smart infrastructure, robotics generally, in addition to automotive. And so Ouster, we want to bring a new digital technology to bear and also to play across those four markets, with industrial being really one of our biggest, if not the biggest market today that encompasses warehousing.
Yeah, absolutely. And it's very interesting. And, I think it's interesting because you mentioned there, back in 2015, it was about, how do we get these vehicles on the road, autonomous, right, and driving on their own and things like that. But I think and seeing, some of the evolution of technology in the warehousing industry specifically, it seems like a lot of this tech that is somewhat started as like, this is going to be something that's going to impact the daily consumer lives, like robotics and AI and machine learning and, autonomous vehicles and things like that. It seems like that a lot of that tech has like rolled back from the idea of like, it's going to roll out to the consumer first and actually like come into the warehouse initially. So I'm curious, what do you think about that as you see out there in Silicon Valley? Like how is the idea of consumer facing tech versus tech that's actually really getting proven out and getting practical applications like in the warehousing space?
Yeah, actually, this is one of the things that's so interesting about there's, I guess, Silicon Valley has been pushing the forefront of robotaxi and high automation technology. But the reality is that there's been advanced driver assistance systems in industrial and a version of automation for the last 20, 30 years. And actually, it's been powered by a legacy Lidar technology. So one of the reasons we founded Ouster to play across these markets is because there was already a market for Lidar sensors in industrial and for automation technology in industrial, smart infrastructure, robotics. And so these are attractive markets to go out and play in, just because we're not creating an all new technology or capability like robotaxis. So I absolutely think that it has been the case, and it will always be the case, that for safety critical technologies that start at higher price points and then come down the cost curve while increasing the volume curve, that they're going to start in industrial. And certainly that's the case with Lidar and with automation technology. So, we're working with some customers, OEM manufacturers of forklifts or other industrial equipment, AGVs, and they use Lidar sensors all over the vehicles. And their logic and intelligence is somewhat simple, right? They follow a line through a warehouse that's on the warehouse floor, but they can detect an object. They don't know it's a human. They don't know if it's a pallet, but they can stop and keep that work environment safe. So it's constrained where we are today with the kind of warehousing technology, but it is effective and it's widely deployed. There's over $2 billion worth of industrial Lidar sensors that are sold every year. Oh, wow. And a big fraction of those are sold for automated ground vehicles that are operating in warehouses and manufacturing floors, kind of in mixed use environments. So absolutely, I'm a big believer in industrial technology, and you don't just have to believe in it. You can go and see it in any modern warehouse today. You'll see machines moving goods without human intervention.
Yeah, absolutely. An interesting perspective there and points. So no, we mentioned Lidar here a couple times, and a lot of people that listen to the podcast are not necessarily tech people, right? They're in the warehouse, right? Or they're learning about automation through the podcast or different avenues and starting to understand what these things can do and how they operate. So why don't you give us kind of what is Lidar for those that may have heard the term but not exactly sure what is it, how does it work, what really is Lidar?
Yeah, sure. So Lidar stands for light detection and ranging. It is similar to sonar or radar. The fundamental idea is that you emit a pulse of light in the case of Lidar, or radio waves in the case of radar, or sonar is sound. And you emit that from the sensor and start a stopwatch. That light goes out, hits an object, reflects, and comes back to the receiver in the sensor. And when the light comes back, you stop the stopwatch. And with that and the speed of light, you can calculate the distance to all those objects in the scene. And that's the same principle that sonar uses with sound, or that radar uses, or bats use with echolocation. So it's a detection and ranging technology, and Lidar is just using laser light to do it. And Lidar typically has much higher resolution than these other technologies because it's an optical technology. We fire millions of laser pulses every second in all different directions around a vehicle and build up a 3D view of the world where we've kind of probed every object in the scene with millions of these laser pulses to get data about the 3D structure of the environment. So Lidar is really the last fundamental detection and ranging technology that is yet to be widely commercialized and made affordable. Today you can drive in a car that has radar sensors, ultrasonic sonar sensors, and cameras. Those are widely deployed and affordable technologies. And LiDAR is kind of the final fundamental sensing modality that, Ouster is here to commercialize.
Interesting. Yeah, good explanation. And so, I mean, essentially the LiDAR is, if you look at it like an autonomous robot in a warehouse, LiDAR is how the robot is basically seeing, correct?
Yeah, it's the eyes. Yeah, it is the eyes. And in many cases, it is the only eyes on the vehicle. There are no other sensors in the system but the LiDAR sensor. And so without LiDAR sensors, in these AGVs that are already deployed, they wouldn't function. They wouldn't be able to detect that a person's leg is in the direction of travel of the AGV and stop. And so one of the benefits of LiDAR over these other technologies like cameras, you ask why is LiDAR important versus cameras, which are already affordable, you can buy off the shelf. And the fact is that LiDAR measures exactly what a computer system cares about when it wants to sense the world, which is the 3D information, the 3D shape of everything in the scene. And that's information that a computer can parse and say, oh, there's ground here, there's a pole that I need to avoid. We're directly detecting those hard objects in the scene and allowing a robot to maneuver around them and stop if they come too close to the direction of travel. Cameras, on the other hand, measure a 2D scene, and then you need to apply machine learning on top of that image in order to derive any kind of 3D information about the scene. And that turns out to be a very hard problem that's still a subject of intense research and is not reliable. And actually, the proof in this is just that LiDAR has been widely commercialized already in industrial in this more limited, legacy way. So LiDAR sensors today are a safety certified technology in AGVs and other manufacturing equipment, to the point that they're safety certified for human operation. So laser safety curtains and AGVs are guaranteed to never hit a human in a manufacturing environment if they're operating with a certified LiDAR sensor. You can literally trust your life on the data that a LiDAR produces.
No, that's good to know, because we definitely don't want to get hit by a robot, right? So I think that's a very good information there, and obviously a great breakdown of LiDAR and the importance there and what it all means, really. So tell us a little bit about there and how you guys work within the LiDAR space, and also I think you have like a new release, Rev 7. So tell us a little bit about what you guys do with LiDAR and how you work, and also this new release as well.
Sure, yeah. So Ouster is based in San Francisco. We are a roughly 300-person company operating globally, but with headquarters in the Bay Area and manufacturing in Thailand. Okay. And what we've developed is a new type of more affordable and performant LiDAR sensor called digital LiDAR. And it replaces the analog technology that's been in LiDAR, and that's $2 billion worth of analog industrial LiDAR sensors are in all these AGVs and warehouse robots around the world, sold every year. But digital LiDAR is the concept of taking a complex analog system and integrating that capability onto a single silicon chip. So in the same way that your point-and-shoot camera, analog film camera from 2 decades ago, now is a highly integrated, small and affordable digital camera, we're doing the same thing with legacy LiDAR to now digital LiDAR. We've put complexity onto a silicon chip. We design that chip in-house, manufacture it with a partner, and have made a cost-reduced, much more performant, much more compact technology that has numerous benefits in performance, size, form factor, power draw, reliability, and again, affordability. And so what we've done with that is, because it's now a silicon technology, we can improve it at the same rate that computer chips and other silicon technologies improved. Because there's a global $1 trillion semiconductor industry that works on improving these digital chips year in and year out. And that's where we just made another revision, another release of our hardware lineup called Rev 7, which is the 7th revision of our platform of digital products. And what's going on there, we've actually made a new digital chip that we put into all of our products, just like you can buy a new smartphone every year, and it usually has a new digital processor inside that improves the capability of your smartphone. We've swapped in a new digital chip in our Lidar sensors, and now we have fundamentally improved performance in these Rev 7 products. And that's part of the pitch to our customer set, is that once you start using digital LiDAR, not only is it more affordable, more capable today, but we are on this rapid trajectory of further improvement, and you can reap the benefits of that over time if you're an Ouster customer.
Very interesting. So, I mean, it sounds like you're definitely tackling that last part that you mentioned earlier in our conversation, where, LiDAR is like the last one to really be, like fully commercialized and made at a more cost-effective level, right? And it sounds like you're really addressing that and finding ways to be able to develop it faster and advance it faster, but also in an affordable way, which makes a lot of sense for the customer to adopt your LiDAR technology and be able to utilize it in there. So tell us a little bit about some of the partnerships that you've had. I know you've partnered with some of the companies we had on the podcast as well, like Gin and Vecna and Valio. So why don't you tell us a little bit about that and how ultimately you've worked together to make their solutions better and more robust?
Absolutely. So we like you said, we have a good set of customers in warehousing: Syngin, Third Wave Automation, Vecna, Balio, ATI Motors, and a number of other unnamed customers. But what we've done well is make the technology more affordable, make it more flexible, and listen to customers about their needs to solve their problems. So building in neat, little features, nuanced capability that allows them to drive faster, build more efficient AGVs and AMRs, and also enable shared workspaces for the first time. So really what we've been able to do with digital LiDAR is both affordable and perform, but actually we're moving the industry from a 2D, very, very constrained LiDAR technology to what we call 3D LiDAR. Okay. And this is the concept of actually having a camera-like view of the world for the very first time in a LiDAR sensor. So let me step back. So 2D analog LiDAR is a simple technology where you scan a laser beam in one plane around the environment, and it gives a very limited slice of the environment. So if you put that on an AGV, these 2D legacy LiDARs take a slice of the world, and they can see a human's ankles, but that's it. Okay. Right? It kind of takes the slice of data 4 inches off the ground. And so to know that a human is there, actually what you're doing is measuring just the ankles of the human. And it's possible that's actually just a pole in the environment and not a human. And to get around the limitations of field of view and data resolution in that legacy technology, our customers traditionally have just bought many 2D LiDARs and put them all over the vehicle. So some of our customers previously had up to 7 legacy 2D LiDARs all over their AGVs to try to capture different slices of the world with those limited sensors.
Okay. And
now what we've
put
done
them together, I guess, and layer them.
Exactly, kind of stitch them together into a single view. But it's a really limited and complex way to solve a problem like that. Our sensors have a much wider field of view. They output 100 times the data rate. They can see 10 times as far. And they have these very wide fisheye fields of view, just like a fisheye camera. Right. So you can look down to the floor, up to the ceiling, and in a wide 360-degree field of view, literally all the way around the sensor. And so with a single sensor mounted in the right location, you can replace all 7 of those legacy LiDARs and still be producing more data with fewer blind spots and seeing further at the same time. And again, this is all made possible by this digital technology that's just superior because of the investment that the semiconductor industry has made into high-performing digital semiconductors. And so what this allows is more resolution, better field of view with no blind spots. It means simpler systems that can drive more quickly while still maintaining safely. Because if you can see further away with better resolution, you can sense humans further out more reliably and other obstacles in your environment. And you can also build great maps of a warehouse. So many of our customers they're simultaneously navigating a warehouse environment to deliver goods, and also mapping the warehouse shelves to understand the state of the warehouse and, stock and things like that. And so there's this dual use that happens between efficiency, safety, actually triple use, efficiency, safety, and awareness of kind of mapping of the warehouse. And then the other thing that it enables is this mixed use warehouse. So because the machines are more intelligent with better sensing capability, we're also seeing customers that have started to allow humans to operate or work more closely next to the machines because they're better able to sense the presence of the human and maintain a safe work environment.
Yeah, it makes definite sense, and obviously I can imagine the safety increase when you talk about only really measuring like at ankle level, right? Versus, being able to get the full picture of what's really going on around the AGV or the robot, whatever the case may be. I can imagine then that does allow you to have that closer proximity and allow you more flexible workspace, like as you just mentioned. So is if I look at your website here, and I'm seeing where it says Rev 7 and there's like kind of little video playing. I mean, is that actually like what it looks like, and that's what like the Lidar sensor would be picking up and seeing?
We'll be back after a quick break.
You hear a lot about supply chains these days, because if the past couple years have taught us anything, it's that an efficient, well-managed supply chain is absolutely critical to keeping businesses successful and consumers happy. I'm Will Haywood, and I host a podcast called All Business, No Boundaries, where we talk about supply chains, how they work, what happens when they don't, and the innovations that are redefining what's possible in the world of logistics. Join me for insightful interviews with thought leaders and industry experts. We discuss how optimizing supply chains can break down the barriers that are holding businesses back. That's All Business, No Boundaries by DHL Supply Chain. Listen and subscribe wherever you get your podcasts.
Yeah, absolutely. So if you go to our website, all those videos, that data is called a point cloud.
Okay.
And it's a point cloud because it's a cloud of points, kind of, that are the measurements that the Lidar is taking every second in all directions of the environment. So that's the data that I said you can literally trust your life with the measured data that a Lidar produces. And so, yeah, it's a pretty impressive set of data. A human can interpret it because it's so high resolution. It's really capturing the entire 3D environment each and every second, literally millions of points of data produced all around the device every second.
Yeah, absolutely. Because I see the video and you can tell exactly what it is. I mean, it's a road with like palm trees on the side of it, right? So, I mean, it's very much as like it's a real-time video feed. It just looks like maybe it's a filter on it or something, like from Instagram maybe. So something like that. So really interesting dive into the technology and how it works and what it means. So if we look at that and, say I'm a warehouse operator, manager, project manager, something like that. And we're looking at, our warehouse, our fulfillment center, and we're trying to decide what's the right automation solution to bring in here, or what things should we consider. So now when we look at the sensor technology, why should someone be concerned about whether technology is utilizing Lidar or utilizing some other alternative for sensor, maybe camera or something like that? Yeah.
And so this is the age-old question of camera versus Lidar sensing. Which one is better? Why use one versus the other?
Yeah.
It's a question that other customers and other, in our automotive vertical, customers ask this sometimes as well. The reality is, sitting in my seat, I see customers that have, ultimately decided not to use Lidar, or potential customers that ultimately have not decided to use Lidar, and then a year later come back because they've failed to build the automation that they thought was possible with cameras. And so they have to come back and say, no, this is really only a tractable problem if we use Lidar sensing. And so I've seen that. That's just a very common kind of storyline for customers that go a camera route. And the reality is, Lidar is already used today in these settings very effectively. It has been used for the last 2 decades, despite being limited in many, many ways. Like I described, the 2D slice, you can only see a person's ankles with the data, but still, you can trust your life on that data. If you see something with a LiDAR sensor, you can trust that it's there, and you should, and you can pay attention and navigate around it. That is not true of camera technology. Cameras don't work when the lights are off. Cameras don't work when there's a shadow cast through a window or a skylight. Cameras don't work in environmental conditions, if it's an indoor, outdoor work environment. Right. And most importantly, cameras, in order to do any of this work, have to be trained with a black box machine learning AI network that is impossible today, still impossible to prove how it works and if it's going to work in all settings. So for all those reasons, we see customers really struggle to accomplish their automation goal with just cameras. Right. And despite the technology, the sensing technology being widely deployed, obviously, in everyone's smartphone and everywhere else. So when you're looking at actually automating it, LiDAR allows you to really just address the end problems you're trying to solve and get away from building the eyes of the machine and just use the data output to solve your automation problem. Think about navigation and business logic versus fundamental kind of machine perception. That's what a LiDAR sensor does really well. And the other thing I would say is just that LiDAR is a cost competitive technology. Okay. I think that LiDAR is viewed as a premium technology because I think it historically has been. But because we're replacing many LiDAR sensors with a few units, because of the better field of view and resolution of our modern digital LiDARs, we can save overall system cost. In some cases, we're replacing 5, 7 LiDAR sensors with a single LiDAR sensor, or 1 or 2 LiDAR sensors. That's 5 times less cabling, 5 times less computation that needs to happen across a different set of, across multiple sensors, 5 times the reliability of the overall system, the hardware reliability and ruggedness of the system. So there's a lot there are a lot of benefits that come from moving to a digital LiDAR platform.
Very interesting, and I think that's a great way to put it, and certainly a great way to get in the minds of people when they're considering, the types of solution and what to consider as well, especially if they're getting into some of these robotics and autonomous vehicles for the first time as well. So really great insights there. So I appreciate that. And as we kind of get to wrap up here, how do you, being that you're seeing what's happening in the autonomous market and reacting to that and developing sensors that are helping people to accomplish what they are looking to accomplish with their ideas in this space, how do you see autonomous equipment, kind of specifically in the warehousing industry, evolving over the next few years?
Yeah, well, it's interesting. There's a 2-pronged approach in automation in the warehouse that I've seen. Okay. One is human assistance, driver assistance technology, right, where actually the LiDAR sensor is not necessarily driving a forklift or a forklift, and it's actually a safety system that's there to monitor the human driving and prevent a collision. And I've seen a ton of success from that. And that's where, by the way, automotive technology right now is in the driver assistance world. ADAS is a big business, right, and any modern car has a driver assistance system in it. Yeah. And now I'm seeing more and more of those driver assistance systems deployed into manufacturing, warehousing, and other industrial settings. I think that's a really effective model because it's a tractable technical problem. It's more easy to scope. And at the end of the day, what I'm talking about is it's a system that would beep if an operator is about to back into a warehouse shelf or a pallet or a human, right? Really simple at the end of the day and very effective. And so I'm excited for that to be mass deployed, and already is with a number of our customers. And then there are the customers that are moving towards full automation. And I think that with the right scoping of the problem, you can build fully automated vehicles that are highly efficient, flexible, and affordable. And we've seen that with a number of our partners. And we have great customers doing fully automated systems, and they're scoping the problem in a constrained enough environment to really deploy this technology at scale. And then the next decade is just going to be about making that technology more and more flexible, faster to deploy, more affordable, and more applicable to a diverse set of use cases.
Yeah, very interesting. And I will say that the driver assist technology, I mean, we've seen it in cars for quite a while now. And I think that it coming into the warehouse and being with forklift is like long overdue. Like, I feel like there's like, I mean, I know there's a lot of car accidents and things like that, but I feel like being in the warehouse and just seeing how things go, I mean, there's like, it just seems like, bumping into the rack or something is something that happens, just all the time. And I don't know why we haven't done this like sooner. Like it makes so much sense, right? Because there's so much going on, and the forklifts are dangerous too. I mean, so it's awesome that you're seeing that coming, and then also the fully autonomous as well. I think is a huge thing, and I think it's going to be very interesting to see how that develops. And I think that it sounds like the Lidar is probably going to be the big tool to help to make sure that it's sensing and seeing these things and being able to be reliable, like you said, being able to trust it with your life, I think is a huge thing, and will take away some of that doubt that people are a little maybe skeptical or afraid about robots just kind of not necessarily freely running around, but running around in a non kind of restricted area. I think is a really interesting thing. So thank you very much for coming on the show, Angus, and talking to us about Lidar and Ouster and giving us some knowledge here and some Lidar 101 and how it impacts our warehousing industry here. So if people are interested in learning more about Ouster, how can they do that?
They can go to our website. Our website has a great blog where we've written about a number of different topics, including AGVs, warehousing, robotics. So that's a fantastic resource. And you can always contact our technical team. We are responsive and are happy to answer questions if there are any. But again, I'd go to our website and take a look at our blog and other pages, because we really have devoted a lot of content to the warehousing and industrial space.
All right, great. And we'll definitely put all that information. It's ouster.com, and we'll throw that on the newwarehouse.com as well, so people can easily access it and get to it and check out some of those great resources you were mentioning. So Angus, thank you once again for your time on the show today.
You've been listening to the New Warehouse Podcast with Kevin Lawton. Subscribe and check us out online at thenewwarehouse.com.
Thank you for listening to this episode. If you want more content from the New Warehouse, check out our new video series called All Hands on LinkedIn. Just search for the New Warehouse on LinkedIn and follow along.